All right, everybody. Hello and welcome back. This is a regularly scheduled lesson like we've done in the past. So today we're back on track. Today, this is 6.5, and we're looking for a title, which is Applying Systems of Linear Equations. So what this means is, in the past we learned all kinds of strategies to solve our problems with more than one equation. Today, our goal is going to be to determine which of the strategies we learned is the best suited for each problem. So, of course, there's multiple ways to solve each problem. We just want to choose what strategy is going to make it the easiest possible. So we have all these tools of ways to solve. We did graphing, we did substitution, and we did elimination a couple different ways. So now we can use any of those strategies we want to solve our problems. We're going to try to choose the best one, the fastest one, and then work through those problems. So the goal with these problems we're going to see today is to determine which one will work the best. So we're going to apply all of that to best solve our problems. Okay, so here are the ways of solving that we've already talked about. The first one you see is graphing. That gives us estimate solutions, but it's not going to be exact unless your graphing is just absolutely perfect. But graphing is a method to solve. Substitution works best when you have your coefficient of your variable is 1 or negative 1. So what that means is, say you have an equation like y equals 2x minus 1. Well, it's already solved for y. It has a coefficient of 1. There's just one y here. If it's something like that, you want to substitute because you already have y equal to a bunch of stuff and you can replace it. So substitution is one we also learned. We did elimination using addition and subtraction last week. And we want our variables to have opposite sign coefficients. Subtraction is when they have the same coefficients you could subtract, but we talked about changing all of the signs, switching the signs and then adding them down. And then we talked about elimination as well with multiplication. So that means you have to multiply to get the same coefficient and then eventually solve the problem. So here's a bunch of strategies. We'll now choose which one is best depending on what we got to work with. So with that in mind, we're going to get started with a first example. So example 1. Don't worry about the words, just start with our equations. So first, we see 2x plus 3y equal to 23. We also see 4x plus 2y equal to 34. Now the whole goal of today is to work through your thought processes, okay? So what method would work the best based on what we see? Now it's okay to solve a problem different ways. There are many ways to solve the same math problem, so there's no necessarily right answer, but there are some strategies that will be faster. So let's understand. To determine the best method to solve our system, we've got to look closely at the coefficients. So this word here, coefficient, just applies to what number is in front of our variable. So we see we have a 2, a 3 here, a 4, and a 2. So you have to compare those. We can talk about eliminating, but we clearly can't just add these together and eliminate anything. 4 and 2 is 6, 3 and 2 is 5. None of those disappear. We wouldn't do substitution either since none of this is solved for a variable. Let's think about what we would have to do. So here, as we begin to plan, neither coefficient of x nor the coefficient of y are 1 or negative 1. So what that means is all of these are multiples. So we can't really use substitution because none of these are solved for a variable. Could we use substitution? Yes, but would it be the easiest? No. But we also know our coefficients are not the same for either x or y. We already said that. So we can't eliminate by just adding. So how can we solve this problem? Well, we can eliminate, but we're going to have to multiply. Eliminate using multiplication. So what could we multiply by? Well, we have to first choose which variable we'd like to eliminate and then go from there. So we'll do that on the next slide. Okay, so we want to solve first by multiplying the first equation by negative 2. So the coefficient of the x terms are what we call additive inverses. Fancy way of saying they're the same number, one's positive and one's negative, and then we add them together. So here's an equation given. Here's another equation given. If we multiply this whole first equation here by -2, our x's will cancel out when we add those together. So multiply this whole equation here by a -2. Then this will come out to be a -4, -4 and +4, the x's disappear. That's what we want. So rewrite everything. So rewrite the first one when you multiply, gives us this. Notice everything doubled and the signs changed. In our second equation, this all stayed exactly the same. So this, we just rewrite it right under here. Only had to change the first one because now we have what we want. We can eliminate the x's. So just go ahead and add straight down. The x's disappear. -6 plus 2 is a -4y. And -46 plus 34 is -12. That's the hard part. Now from here, it goes really fast. So to solve for y, we're going to divide both sides by that -4, and y will be a +3. And now you should be thinking, as we attempt to solve the rest of the problem, how do we find x? Well, we just found y, so we can plug in a 3 for y in any equation here and solve whatever is left. So we will finish this up. Just a couple more steps on the next slide. Okay, so substitute in 3 for y. What do we get? Well, we plug in there. We know 2 times 3 is 6. Subtract 6 from both sides, and 4x equals 28. And 4 times what is 28? Well, divide both sides by 4, and x, you know, has to be 7. So x is 7, y is 3. So our answer, the solution is the ordered pair, 7, 3. Done. Now, this isn't really new material at all that we're doing today, but we're just working through all the tools we practiced to understand when each strategy is best appropriate, which strategy is best suited. So there's another example of eliminating using multiplication. And we can check that to be true, and we know it is. All right. So here's 1b. Just write down the equations, and we'll talk about the words here and how we generated those. So at the school pool party, Mr. Lewis bought 1 adult ticket and 2 child tickets for $10. So that's how this first equation came about. So 1 adult ticket, we'll call that x. 2 child tickets, we'll call child tickets y. 4 is going to mean equals and 10. X plus 2y equals 10. That's where this came from. Next one, Ms. Vroom bought 2 adult tickets, so 2x, and 3 child tickets, that's 3y. 4 means equals, and 4 is 17. 17 is here. So that's how we generate the 2 equations. They tell us now the following system can be used to represent this situation, where x is the number of adult tickets and y is the number of child tickets. So determine the best method to solve the system of equations, and then solve it. Okay, so substitution we would only use if we have one variable by itself on one side of our equation. We don't have that, so we're not going to use substitution. We don't want to graph either because that's a lot of work and that's going to take a while. So let's use elimination to solve. And if we use elimination, we're going to have to do some multiplying to figure it out. How do we know we need to multiply? Well, here we have a 1x, here we have 2. So these are not the same, so that wouldn't completely disappear. Here we have 2y's and 3y's. If we were to add those together, that's 5y's, so those don't disappear either. So we're going to have to do some multiplying. I know if I were to make my x here a -2, then that would be the additive inverse. That would be the same number with the opposite sign. And my x's would disappear. So I'm going to multiply the whole first equation by -2. My second equation is going to stay the same. So as I rewrite, my second equation is going to be the same, so I'll just go ahead and copy that. And we should be doing this together in our notes. Great. And my first equation, I'm going to now rewrite when I multiply. -2x minus 4y is equal to negative 2 times 10 is a negative 20. Great. Now once we have this, now we're back to just adding our equations together and eliminating straight down. So 2 and 2, I'll change my color as we finish up. 2 and 2 is 0, so that's eliminated. Plus negative y equals negative 3. So we have here negative y equals negative 3. If you were to divide both sides by negative 1, you know y equals positive 3. So y equals 3. Great. So we're almost done. Now to find x, we just have to plug in 3 for y into any of our equations. So we were already given our first equation here, all right, is x plus 2y equals 10. Now we already know what y is. We just said it was 3. So I'm going to go in here and plug in the 3 that we know is true instead of writing the y. These are being multiplied here. And now we can solve for x. So x plus 6 is 10. And we should be thinking now, what number plus 6 is going to be 10? Well, if we subtract both sides by 6, x has to be 4. And that's true because 4 plus 6 is 10. So we have 4 comma 3. Our x value goes first, y value second. So 4, 3 should be our solution. And do we see that? Yes, we do. So 4, 3 is our correct answer. You could use substitution to solve it. We just did it using elimination. There's no right or wrong answer with what strategy to use. You can use whatever you want. Some will just be faster than others. But our answer for this one is 4, 3. Solve it how you like. I showed you one method. You may use another one as well. All right. So 2a. So we've got a bunch of words. We'll turn it into some equations, so don't worry about the words as we look into the details here. So we're talking about car rental. Ace Car Rental rents a car for $45 and 25 cents per mile. Another company called Star Car Rental rents a car for $35 and 30 cents per mile. We want to know how many miles would a driver need to drive before the cost of renting a car at Ace and at Star are the same. So for what price would it be the same for both companies? So let's talk about it. We can call X the number of miles and Y the total cost of renting a car. So if those are true, we would generate these two equations. The cost of renting a car at Ace is $45, 45, plus 25 cents per mile. 25 cents times X the number of miles. Same process for Star Car, $35 fee plus 30 cents per mile gives us this equation. Now we have those two. They ask us when would the cost be the same? So when would they be equal? So have the equations. We're going to work with those as we get going on this problem. So just make sure you have y equals 45 plus a quarter x and y equals 35 plus 30 cents x. Good. All right. So we want to subtract the equations to eliminate the y variable. So we have those two. Now if you're just looking and you forget all of this context, if you're just looking at these two equations and you want to think, how can I solve it? One way you could do it would be to subtract the equations. In other words, eliminate y. So you can write the equations vertically, make sure everything's lined up. So you have your y's, your constants, and your x's. That's fine. We want to eliminate the y's. So 1 minus 1y would disappear it. But we have to remember that the negative applies to everything. So I told you when we go to do subtraction, we really want to do addition and just change all of our signs. So if you make this a plus and then change the sign of everything here, that's the same thing as subtracting. And now when you go to solve the problem, it's very fast and easy because you can just add straight down. Subtraction will confuse you. Addition is much, much better. So y plus negative y is 0. So we get 0. Now all these numbers make sense. 45 minus 35 is 10. And 0.25 minus 0.3 is negative 0.05, or a negative nickel. Great. So now you just have to do a couple algebra steps to solve for x, and then we're halfway home. So you can subtract 10 from both sides, and now you want to get x all by itself, so you can divide both sides by 0.05 or multiply by 20, either one. And you would get x equals 200. So x is 200. Now to find y, we just need to now go back, plug in this value for x, find out what y is in either equation. So we have 200 for x. We're halfway home. Now we want to substitute in 200 into either equation. So you literally just pick which one you want to plug it into. It doesn't matter. This was our first equation, so we start there. Now we're going to plug in, so the red x, we know our value for x is 200 because we just found it. So go ahead and change that to a 200. Looks like that. Now we got to multiply through and solve to get our final answer for the y value. So a quarter of 200 is actually 50. And 50 plus 45 gives us a nice number that's going to come out to be 95. So y is 95, x is 200. If we're going to write our answer, which one goes first? Well, hopefully we know by now it should be the x value. So answer, 295. So what does this mean in terms of our problem? Well, the solution is 295. This means that when the car has been driven for 200 miles, since that was x, the cost of renting a car will be the same, $95 at both rental companies. So that answers our question. How much would you pay at both? 95. And you pay the same amount when the car has been driven for 200 miles exactly. Because this 200 was our x value. That's our x. And the $95 was our y in our answer. So turning our ordered pair here into some real context with the miles and the dollars. But in the end, this is our solution. So you can have that down with our steps for this 2A real world problem. Hopefully all that makes sense. We're going to work through all of this, but I'm telling you now, the majority of the time when you're going to solve these problems, you're going to use elimination. So if you're still not comfortable with it, hopefully you will be pretty soon. You should make yourself comfortable with it because we're nearing the end of this chapter. It's going to be time for our first test of the semester, which will have a huge impact on your grade. All that in mind, here is a 2B problem. So, given all this info, we got to generate some equations. So let's do it. So 2B is about video games. It tells us the cost to rent a video game from Action Video is $2 plus 50 cents each day. The cost to rent a video game at another company called TV Rentals is $1 plus 75 cents per day. After how many days will the cost of renting a video game be the same at both places? Great. So this is exactly like the one we just did, but instead of talking about the other kind of rental companies, we're talking about video games. So Action Video. If we call, I'm going to say X is the number of days. Number of days. Great. And I'm going to say Y. My Y variable is the total cost to rent. I'll just put total cost. We can just write that. All right. So if X is the number of days and Y is the total cost, we can now write our equations. So for Action Video, our total cost is going to be $2 plus, they tell us 50 cents per day right here. So that's 0.5, 0.5 times X the number of days. Great, that's Action Video, the cost per day for all that. Now how about for TV Rentals, where our total cost Y is going to be equal to $1 plus 75 cents per day. 75 cents, 0.75 times X the number of days. Great. Now they ask us, when will they be the same? So we need to solve this system of equations and see what value of x and y is true for both of them at the same time. So we see we have a y and a y, so we could eliminate these by subtracting. So if we were to subtract one from the other, the y's would disappear. But remember, I told you, you always want to do addition if you can. So instead of subtracting, we're going to do a little trickery here. And we're going to change this to a plus sign. So we're going to add, but then we're going to change the sign of each term. Because this is doing the same thing as subtracting. But now all we have to do is just add everything straight down, and our y's will disappear. So y plus a negative y is 0. 2 minus 1 is 1. 0.5 minus 0.75 is negative 1/4, or 0.25. Great. Once we're at this step, we can subtract 1 from both sides. And now negative 1 equals negative 0.25x. Now from here, you can divide both sides by 0.25, and it would be by a negative. And we're going to bring this up here. X would be equal to a positive 4. So x is 4. If x is 4, what is y? We can plug that into an equation. So if we had y, this is our first equation. First equation taken from here. We're going to copy that. Y equals 2 plus 0.5 times x. But instead of putting x, we're going to put what we know it to be. It is 4. And now we can solve for what's left. So y equals 2 plus 0.5 times 4. That's 2 plus 2. And we know 2 plus 2 is 4. So y is actually also 4. So what are we asked? After how many days will the cost of renting be the same? Well, which one of these is days? It actually doesn't matter since they're both 4. But days is the x variable, so that is this number. So we know our answer is 4 days. After that amount of time, it will cost the same for both companies. That's useful because if you're comparing them, if you're less than 4 days, you would choose one company. If you're going to rent for more than 4 days, you would choose the other based on how much they cost you. This is a real comparison type stuff. You're going to have to make these kind of economic decisions when you're deciding maybe whether to rent a movie from Redbox or to rent a movie from Amazon. Those kind of decisions based on the cost happen every day, all the time. So this is just one example of that, using our system of equations to solve those problems. We're getting close to the end of the chapter. We're going to keep reviewing this stuff, but the time now is for you to practice and work through these examples as we get closer to the end of chapter 6.